Today, we're diving into something pretty amazing: how a craft that's thousands of years old is getting a 21st century upgrade. This is a story about the clothes we wear every day and how cutting-edge code is fixing tiny flaws that have been around forever. I mean, think about it. We are literally surrounded by fabric all day long. So what's the difference between that favorite t-shirt you've had for years and one that falls apart after a few washes? Well, a lot of the time, the answer is hidden in the way it was made. And we've all had that frustrating moment, right? You find a piece of clothing you love, and then you spot it. That one tiny snag, that little imperfection that just bugs you. For the people making the clothes, those little flaws are a huge deal. They mean wasted time, wasted money, and, unhappy customers. But what if a lot of these flaws aren't just random mistakes? What if they're actually caused by a single, hidden problem deep inside the weaving process itself? An invisible force that weavers have been trying to control since the dawn of time. Okay, so here's how we're going to unpack this. We'll start by looking at the flaw itself. Then we'll get into something called the tension tightrope. We'll see how engineers built a digital version of a weaving machine, how algorithms found the perfect solution, and whether it actually worked in the real world. And finally, what this means for the future. All right, first up, the flaw in the fabric. So when researchers really started digging into what causes these imperfections, they found something fascinating. A huge number of fabric defects weren't random at all. Nope. They could all be traced back to one specific, super sensitive part of the weaving process. And that one thing brings us to what we're calling the tension tightrope, because the whole secret to making perfect fabric comes down to getting one thing right: warp tension. It's a total balancing act. So, picture a loom. You've got all these threads stretched out from front to back, right? Those are the warp yarns. Warp tension is just how tight those threads are pulled. And the best way to think about it is like you're trying to tune thousands of guitar strings, all at the same time. Every single one has to be just right. And this is the constant battle. If you pull the threads too tight, they get brittle and just snap. But if they're too loose, they get all tangled up and create a mess, which leads to all sorts of flaws. The perfect amount of tension exists in this incredibly narrow little window. It's a real tightrope walk. Now, for centuries, getting this right was pure art. It was all about a weaver's gut feeling and years of experience. But some engineers decided, you know what? Let's treat this like a physics problem. I mean, you can't just go and fiddle with the settings on a massive industrial loom. Every time you try something new, the machine is down, you're wasting expensive yarn, and it takes forever. They knew there had to be a smarter way to find the perfect settings without even touching the real machine. So their solution was brilliant. They basically built a digital twin. Think of it like a super realistic flight simulator, but for a weaving loom. They broke down the physics, turned all the movements into math equations, and built a computer model that could perfectly predict the warp tension. And of course, they checked it against a real loom to make sure it was spot on. Okay, so now they have this perfect virtual loom. They can test any setting they want without wasting a single thread. Awesome! But that creates a new challenge. Out of the millions of possible settings, how in the world do you find the absolute best one? Well, to do that, they unleashed a couple of digital experts on the problem. Two different kinds of algorithms. The first was a genetic algorithm. It kind of works like evolution. It tries a bunch of random settings and slowly breeds them together until the best one emerges. The other was a gradient-based method, which is more like a heat-seeking missile. It just calculates the fastest way to get to the best answer and goes for it. So the genetic algorithm went to work. Being the thorough one, it took its time, explored a ton of options, and after about 5 minutes on a regular computer, it came back with a set of really good optimized settings. Pretty cool. But then they ran the other one, the gradient-based method. And get this, it found almost the exact same perfect settings in less than 10 seconds. That's just an insane difference in speed, a true showcase of how powerful these mathematical approaches can be. So now we get to the real moment of truth. All of this is great in a computer simulation, but does any of it actually work on a real, physical, noisy weaving machine in the real world? The results were, frankly, amazing. First off, they measured the tension on the yarns, and it dropped significantly. You can see it here. It went from over 132 down to about 106. In simple terms, that means way, way less stress on every single thread in the machine. But it gets even better. It wasn't just that the tension was lower, it was also smoother. The tension was more consistent throughout the whole process. And anyone in the textile world will tell you that a low, constant tension is the absolute holy grail for making top quality fabric. So, what's the bottom line? what actually happened. The quality of the fabric didn't change. The speed of the machine didn't change. But the defects, the little flaws that started this whole thing, they were completely gone. Vanished. The algorithm worked perfectly. And this isn't just some one-off experiment. This whole story is a perfect example of a huge wave that's washing over the entire textile industry. Data, AI, and automation are fundamentally changing one of the oldest manufacturing processes we have. In fact, companies like Smartex are putting these ideas to work in factories right now. They're installing smart camera systems with AI that literally watch every single thread as it's being knitted or woven, catching problems the instant they happen. And check out this data from one of their clients. The AI isn't just saying, hey, there's a flaw. It's saying, hey, 87% of your flaws are coming from this one specific part of the machine. That lets factories stop guessing and go right to the root of the problem. It's a total game changer. And you can see the real-world impact. Here's a quote from a manager at a knitting company. He's talking about fewer defects and more production, yeah, but also about the newfound freedom the system gives his workers. That's the human side of all this technology. It really makes you stop and think. Weaving is an art that goes back to the very beginning of human history. And if data and algorithms can help us perfect a skill that ancient, making it better and more efficient than ever before, it just makes you wonder, what other timeless craft is next?